Today I'm going to tell you about roller coasters. A roller coaster is a type of amusement ride that employs a form of elevated railroad track designed with tight turns, steep slopes, and sometimes inversions. People ride along the track in open cars, and the rides are often found in amusement parks and theme parks around the world. The oldest roller coasters are believed to have originated from the so-called Russian mountains, specially constructed hills of ice located in the area that is now St. Petersburg, Russia. Built in the 17th century, the slides were built to a height of between 70 and 80 feet, had a 50-degree drop, and were reinforced by wooden supports. Later in 1784, Catherine the Great is said to have constructed a sledding hill in the gardens of her palace at Ornai-Baum in St. Petersburg. In 1959, Disneyland introduced a design breakthrough with Matterhorn bobsleds, the first roller coaster to use a tubular steel track. Unlike wooden coaster rails, tubular steel can be bent in any direction, allowing design to incorporate loops, corkscrews, and many other maneuvers into their design. Most modern roller coasters are made of steel, although wooden coasters and hybrids are still being built. The cars on a typical roller coaster are not self-powered. Instead, a standard full-circuit coaster is pulled up with a chain or cable along the lift hill to the first peak of the coaster track. The potential energy accumulated by the rise in height is transferred to kinetic energy as the cars race down the first downward slope. Kinetic energy is then converted back into potential energy as the train moves up again to the second peak. This hill is necessarily lowered, as some mechanical energy is lost to friction. Not all rides feature a lift hill, however. The train may be set into motion by a launch mechanism such as a flywheel launch, linear induction motors, linear synchronous motors, hydraulic launch, compressed air launch, or drive tie. Such launch coasters are capable of reaching higher speeds in a shorter length of track than those featuring a conventional lift hill. Some roller coasters move back and forth along the same section of the track. These are known as shuttles and usually run the circuit once with riders moving forwards and then backwards through the same course. In 2006, NASA announced that it would build a system using principles similar to those of a roller coaster to help astronauts escape the Ares 1 launch pad in an emergency. Although this has since been scrapped along with the rest of the Ares program. Roller coasters are divided into two main categories: steel roller coasters and wooden roller coasters. Steel roller coasters have tubular steel tracks, and compared to wooden coasters, they are typically known for offering a smoother ride and their ability to turn riders upside down. Wooden coasters have flat steel tracks and are typically renowned for producing airtime through the use of negative g-forces when reaching the crest of some hill elements. Newer types of tracks, such as I-box and topper introduced by Rocky Mountain Construction, improve the ride experience on wooden coasters, lower maintenance costs, and add the ability to invert riders. Many safety systems are implemented in roller coasters. One of these is the block system. Most large roller coasters have the ability to run 2 or more trains at once, and the block system prevents these trains from colliding. In this system, the track is divided into several sections or blocks. Only one train at a time is permitted in each block. At the end of each block, there is a section of track where a train can be stopped if necessary, either by preventing dispatch from the station, closing brakes, or stopping a lift. Sensors at the end of each block detect when a train passes so that the computer running the ride is aware of which blocks are occupied. When the computer detects a train about to travel into an already occupied block, it uses whatever method is available to keep it from entering. The trains are fully automated. The above can cause a cascaded effect when multiple trains become stopped at the end of each block. In order to prevent this problem, ride operators follow set procedures regarding when to release a newly loaded train from the station. One common pattern used on rides with 2 trains is to do the following. Hold train number 1, which has just finished the ride, right outside the station. Release number 2, which was loaded while number 1 was running, and then allow number 1 into the station to unload safely. Another key to safety is the control of the roller coaster's operating computers. Programmable logic controllers, often called PLCs. A PLC detects faults associated with the mechanism and makes decisions to operate roller coaster elements based on configured state and operator actions. Periodic maintenance and inspection are required to verify structures and materials are within expected wear tolerances and are in sound working order. Sound operating procedures are also a key to safety. Roller coaster design requires a working knowledge of basic physics to avoid uncomfortable, even potentially fatal strains of the ride. Ride designers must carefully ensure the acceleration experience throughout the ride do not subject the human body to more than it can handle. The human body needs time to detect changes in force in order to control muscle tension. Failure to take this into account can result in severe injuries such as whiplash. When it opened in 2005, King Nikko was the world's fastest at 128 miles per hour and tallest roller coaster. Formula Rossa is the fastest roller coaster in the world with a top speed of 150 miles per hour. This roller coaster is located in Ferrari World of Abu Dhabi. Formula Rossa accelerates from 0 to top speed of 150 miles per hour in just 5 seconds. Thanks for watching this Adventurous Kids episode.